Newton's first law, second law. Now we're going to be looking at another law, which is Newton's third law. So before then, let me remind you of the definition of a force. A force, as we've seen or we saw at the beginning, is simply a push or a pull of an object. So whenever you exert a push or a pull, you are doing so on an object. So two things are actually interacting. So when we're talking about interactions, remember it always occurs between one thing and another. For example, when you push against a wall, you are interacting with the wall. Okay. Now, Newton's third law is all about the law of interaction and reaction. So what that says is whenever one object exerts a force on a second object, the second object exerts an equal but opposite force on the first one. For example, when your hand presses on the wall will simultaneously press on your hand. Hand and a wall press on each other with equal and opposite force. And so that's Newton's third law. That for every action, there's an equal but opposite reaction. So, action and reaction. One force is called the action force, and the other force is called the reaction force. They are co-pairs and a single interaction. Remember, neither force exists without the other. They are equal in strength but opposite in direction. They always act on different objects. Let's look at this question. You have a soccer player that kicks a ball with a force of 1,500 Newton of force. The ball exerts a reaction force against the player's foot of, again, remember for every action there is an equal but opposite reaction. So the forces are going to be the same. So when you kick the ball will also exert a force on your foot, and that force is going to be the same as the force that you exerted. Okay, it will be the same. Now, there are many other examples of Newton's third law that exist, right? The simple rule to identify action and reaction force. So, for the action, object A exerts a force on object B. Then the reaction will be object B exerts a force on object A. Simple. So, if you have a car that's driving, right, the action will be the tire pushes on the road, right? The reaction will be the road pushes on the tire. If you have a rocket that's been launched, the rocket pushes on the gas pushes on the rocket. So for every action, there is always an equal or opposite reaction. If you have a man that is pulling a spring, always remember that that spring pulls on the man. The forces are the same. No force exists without the other, but they act in opposite direction always. When you step off a curb, the earth pulls you down. The reaction to this force is, again, there's an if the earth pulls you down, then there must be a reaction that pulls you upward. You pull the earth upward. Action and reaction on different masses. If the same force is applied to two objects of different masses, one thing you remember is that greater mass object is equal to small acceleration. That's Newton's second law. So we'll borrow Newton's second law to explain some of the things here. And a small mass object requires a large acceleration. Don't forget. Let's check this question. When a cannonball is fired, the acceleration of the cannon and the cannonball are different because, again, the acceleration can only be different, right, because of their different masses. But the force acting on them is the same. They only have a different acceleration because the cannonball and the cannon are of different masses. So if you consider a high speed bus colliding head on with an innocent bug, the force of impact splatters the unfortunate bug over the windshield. This is a situation you need to think about. The only reason why this happens is because the bug has a very small mass. Okay? So because it has a very small mass, it will have a very small inertia. If you remember Newton's first law. And so the bus will kind of splatter the bug, not because the bug didn't apply a force on the bus, but it's because the bug has a small mass. Which is greater, the force on the bug or the force on the bus? Again, they are the same. The bug will apply a force that is equal to the same force that the bus applied on it. But the only thing, right? The only thing is that the bug has a small mass. So although the forces are equal in magnitude, the effects are very different. Do you know why? Because they have different masses. Two people of equal mass on slippery ice push off from each other. Will both move at the same speed in opposite direction? Again, always remember that when it comes to Newton's third law, the only thing you can guarantee is that for every action there is an equal and opposite reaction, right? So if two people push against one another, the only thing they have in common is that they have the same force applying on each other, but in opposite direction. But when it comes to their speed, right, you cannot you can't talk about the same speed if you don't know their masses, right? Now, if they have equal masses, like in this situation, yes, okay, yes, they will move in the opposite direction with the same speed because they have equal masses. Okay. If the masses were not equal, then you can't talk about their speed. See? So however they push, the result is equal magnitude forces on equal masses, which produce equal acceleration and therefore equal changes in speed. All right, let's talk about another defining system. So if you consider a single enclosed orange, apply external force causes the orange to accelerate in accord with Newton's second law. Action and reaction pair of forces is not shown. Consider the orange and the apple pulling on it. Action and reaction do not cancel because they act on different things. As you can see, they're acting on different things. External force by apple accelerates the orange. Consider a system comprising both the orange and the apple. The apple is no longer external to the system. Force pair is internal to the system, which doesn't cause acceleration. Action and reaction within the system cancel. With no external force, there is no acceleration of the system. So if you consider the same system but with external force of friction on it, same internal action reaction forces between the orange and the apple cancel. A second pair of action reaction forces exist. So one of these acts by the system that is the apple on the floor, and the other acts on the system, that is the floor on the apple. External frictional force of the floor pushes on the system, which accelerates. Second pair of action reaction forces do not cancel. Let's check this out. When you lift, when lift equal the weight of a helicopter, the helicopter does what? It hovers in mid-air. So there's a lifting force, remember? When you have a lifting force, which is the force that allows the helicopter to kick off. So when that lifting force equals the weight of the helicopter will hover in mid-air. When the lift is greater, right, the helicopter climbs up. So if you have a lifting force that's greater than the weight of the helicopter, then you see the helicopter climbing up. A bird flies by, pushing air down so that the air pushes it up. Right? So it's the same thing even when you're swimming. When you're swimming, if you want to go forward, what do? You push the water backward because for every action, there's an equal reaction. So the same force you're applying on the water backward, that water is going to apply that same force on you forward. That's why you move forward when you're swimming. When you slightly tilted, wings of airplanes deflect. When you look at the airplane, there's always some sliding wing, right? The upcoming air downward to produce the lift. So those wings that you see on an airplane, they're usually meant to push the air downward so that that same air is going to push the plane upward. So when a wing diverts air downward, it exerts a downward force on the air. The air simultaneously exerts an upward force on the wing. The vertical component of this upward force is the lifting force that allows the plane to go up. When you compare with a lightweight glider, a heavier glider will have to push air downward with a greater force. The force on the air deflected downward must equal the weight of the glider. Alright, so that's that for Newton's third law. So make sure you take your notes